Welcome to EE101-1, Fundamentals of Electrical Circuits.
In this video, our goal is to learn what is complex power and apparent power, and to differentiate real and reactive power.
Hello, today we're going to discuss power in AC circuits. First, we have complex power. Complex power is the product of the RMS voltage phasor and the complex conjugate of the RMS current phasor. Its unit is volt-ampere. As a complex quantity, its real part is the real power P and its imaginary part is the reactive power Q. Next, we have the real power, which is expressed in watts, and so represents the actual energy converted from electrical energy to useful work. Next, we have the reactive power, which is expressed in volt-ampere reactive or VAR, and is the energy that is used to help transfer energy into usable work, but does not do any usable work itself. Apparent power. It is the combination of reactive power and true power, and it is the product of a circuit's voltage and current without reference to phase angle. Here is the complex power in rectangular form. Complex power in volt-ampere is equal to real true average power in watts plus the reactive power in vars. So this one is the real part, this one is the imaginary part. Combining, we have a complex quantity called the complex power. In polar form, we have the complex power equal to the apparent power bar angle, which is in degrees or radians, and it is the difference between the angle of the voltage and the angle of the current. Going to power triangle, in our x-axis, we can see the real power P. Y-axis, we have the reactive power Q. And we have the vector here, the apparent power S, and we have the angle theta. So if you want to get the real power P, we can use this equation. Apparent power cosine theta, which is also called the power factor PF. Reactive power Q equal to the apparent power sine theta, wherein sine theta is the reactive factor. The power factor is the ratio of real power to apparent power. And a power factor of less than 1 indicates that the voltage and current are not in phase. Also, it means that the maximum value for our PF factor or power factor is equal to 1. The reactive factor is the ratio of the reactive power to the apparent power. Let us apply our knowledge in this example. So we have here the impedance of the line is represented by 4 plus J2 and a return path. Find the real power and reactive power absorbed by the load. Given this circuit, let's solve for the reactive and real power absorbed by the load. So first, we need to get the total impedance Z, which is equal to 4 plus J2 plus 15 minus J10, because they are in series. And that's equal to 19 minus J8. Or, in polar form, we have 20.62 bar negative 22.83 degrees. So the impedance is measured in ohms. Let's go to the current through the circuit. We have here current equal to voltage over the impedance, or 220 volts. In this case, we have 0 as our angle. 220 divided by 20.62 bar negative 22.83 degrees. And that is equal to 10.67 bar 22.83 degrees. Next one, we need to get the voltage at our load. So V sub L is equal to 15 minus J10 times the current. So this is our load. So we need to get the voltage across it. So we have 18.03 bar negative 33.7 degrees multiplied by 10.67 bar 22.83 degrees. And that is 192.38 bar negative 10.87 degrees. So V sub L is in volts. For the complex power absorbed by the load, we have complex power equal to the load voltage multiplied by the current. So we have 192.38 bar negative 10.87 degrees multiplied by 10.67 bar 22.83 degrees. And that is 2053 or 2053 bar negative 33.7 volt ampere. But in our question here, we need to get the real power and reactive power. So we need to express this in rectangular form. So 1,708 minus J, 1,139 volt ampere. So our real power is this one, the real part, 1,708 watts. And for the reactive power, we have the 1,139 bars.
Summary. Complex power is the product of the RMS voltage phasor and the complex conjugate of the RMS current phasor. Real power represents the actual energy converted from electrical energy to useful work. Reactive power is the imaginary or complex power in a capacitive or inductive load. Apparent power is the product of a circuit's voltage and current without reference to phase angle. That ends our discussion. Thank you for listening.